In Unit 1, we spent time learning how to measure in the lab. The problem we often run into is that sometimes measurements can either be really small or really big. We need a way to handle these measurements in the lab and in various problems that we will encounter in chemistry. One way scientists can handle very large or very small measurements is to use scientific notation like you learned the other day. However, we can also use prefixes in our metric measurements. You are already used to some of these, such as centi, when we measured in centimeters, milli, when we measured in millimeters, as well as when we measured milliliters with the graduated cylinder. But what are these prefixes? What do they mean, and how do we use them? That's what today's lecture is all about. When you completed the skills packets at the beginning of the year, you learned that there were two systems of measurement, the English system and the metric system. Currently, there are only 4 remaining countries that still use the English system to this day. The United States is the main front runner of the English system of measurement. There are also 2 small countries, one Liberia, the other one Myanmar. And the UK, otherwise known as England, is also still using a few of the English system measurements for some of the products and goods that it sells. And then we have the rest of the world using the metric system. The reason why students in America find the metric system so hard is because we weren't raised on it. The metric system is actually easier. You just have to give it a chance. This gargantuan table shows you a number of different prefixes that exist for the metric system. Before you fall over in thinking that you need to know all of them, you don't need to know all of them. I wanted to include as many as I possibly could so that you could see that we can have a prefix for as big as we can get and for as small as we can get. I also liked this table because I liked the factor language over here on the right. In case you were wondering how you read a decimal place or a number with so many commas, we've got the language here if you're not sure what it is. Okay, so what do we need to know from this table? While it's not nearly the entire table, it's still a lot, and I know you're not going to be happy, but it is what it is. We need to learn our metric prefixes. So, although I know everyone has heard of giga, and we're getting into tera with our computers and our tablets and other devices, we are not held responsible for knowing those. But just so you know, a gigabyte is 1 billion bytes of memory, and a terabyte is 1 trillion bytes of memory. All right, are you ready for what you really need to know now? Here we go. We need to know from mega all the way down to nano. You are going to be held responsible for knowing the value of each of these prefixes, as well as being able to convert back and forth within the prefixes. In our next lesson, I will teach you how to do the conversions. Right now, for this lesson, you need to learn the values of each and how you get back and forth between a base unit and a prefix. So what exactly is a base unit? Right here is the base unit. It has a value of 1. Now I know this is an English table because meter is spelled with R-E instead of E-R, but any base unit goes in here. So you can substitute liters, you can substitute grams, seconds, joules, which we'll get to later on in this chapter or the next chapter, and so on and so forth. Bytes, you can use bytes for memory. I know that's important to us with our devices. One thing that I don't care for with this table is the way in which it sets up the equalities for you once you're under or smaller than the base unit. So I'm going to rewrite these for you. 1 meter is equal to, let's see here, 1 billion nanometers. There's not enough space for me to write 1 billion, so I'm going to use 1 times 10 to the 9th nanometers equals 1 meter. A micrometer, we use this Greek letter nu. It's a U with a tail in front of it, basically. 1 million, 1 times 10 to the 6th, micrometers, a U with a tail on it, equals 1 meter. Let's make this a little bit bigger for us so we can see what exactly I'm writing. There are 1,000 millimeters in 1 meter. There are 100 centimeters in 1 meter. And there are 10 decimeters in 1 meter. This is what I would like you to write down in your notes. I need you to copy down the SI prefix, and you know what? Don't call it SI. Let me cross that out. We'll call it metric, prefix and symbol, and then the conversion factors. You don't need to worry about the factor power, and the factor language is simply for your reference. All of these equalities, though, we definitely want to make sure we have in our notes at some point. So we need to make sure we've got all these guys. Let me make sure. Let's see here. So I want you to record in your notes this equality for megameters. And remember, you can substitute in megaliter equals 1 million liters, megagram equals 1 million grams, megaseconds equals 1 million seconds, megajoules equals 1 million joules, megabytes equals 1 million bytes. You also need to know that a kilometer is 1,000 meters, and that kilo prefix can be for any one of our base units. A hectometer is 100 meters, same thing for liters, grams, seconds, joules, and bytes. A decameter equals 10 meters, same thing with our other base units. And then the ones I wrote out here, the decimeter, the centi, milli, micro, and nano. Again, this symbol right here for micro is the letter nu, and it's a U with a tail in front of it. In the 1960s, scientists from all over the world gathered together in France to decide on base units that would be shared internationally among scientists no matter what their nationality. Out of this convention came what we call the SI base units. There are a number of units that have been agreed upon by scientists from all over the world that we consider to be base units, even if they're not base units according to the metric system. We are held responsible for knowing the first several here: mass, length, temperature, time, and the amount of substance. Now, if you're wondering why volume isn't here, it's because since length is the meter, then volume, which is length times width times height, the SI base unit for volume is the cubic meter. Many people assume that we know this simply because length is the meter. While we never actually measure cubic meters in the lab, we will always use a prefix for liters of some sort, mainly milliliters. You need to know that the SI base unit for volume would be the cubic meter. You also need to know the SI base units for length is the meter, for mass is the kilogram, for temperature, Kelvin, time is the second, and the amount of substance is the mole. We'll learn about moles in second semester.